All right, guys, this is our first video for Unit 2, Lesson 1. We are solving linear equations using the properties of equality. Okay, so solve linear equations using properties of equality. Properties of equality or equation means it has an equal sign, right? So an equation is a statement that two expressions have equal value. Yeah. The equal sign makes the left side equal to the right side. 3x minus 1 equals 5. Even though I don't know what x is, because the equal sign is there, I know that the left side, everything on the left must equal everything on the right. We will also solve linear equations by simplifying through combining like terms. 3x plus 2x plus 5. Simplify that to 3 plus 2 is 5x plus 5. So we have the like terms. They both have an x to the first power. So we combine them. Solve linear equations containing fractions or decimals, and recognize identities and equations with no solution. Okay. Linear equations has the word line in it. It means that if I graph, the graph will be a line. Straight line. See if I have any. Let's get rid of this one. 5x plus 1. It doesn't look very straight, but compared to 16x squared x to the first power, because there's no 2, x to the first power is a straight line. X to the second power is a curved line when I graph it. Okay. So solving algebraic equations in one variable involves finding a value for the variable that makes the equation true. Clear grouping symbols and fractions. Use inverse operation to isolate the variable to one side by undoing addition or subtraction, and then by undoing multiplication or division, okay? Because the equal sign makes it true, whatever you do to one side, you have to do to the other side. If I don't, it won't be true, okay? So if I had 5 is 2 plus 3, right? That's true. And I want to subtract 3. If I only subtract 3 from one side, then that would just say 5 is 2, and that's no longer true, right? So I have to subtract 3 from this side. 5 minus 3 is 2. Now it's true again. Anything done to one side must be done to the other side. Okay. Solve and check your solution. A number that we can subtract 4 from to get a 7 for this first one. This first blurry picture, sorry. Let me start over. We're looking at this one. In example 1, In example 1, we'll call this number 1. Okay? What is a number I can subtract 4 from to get a 7? Or what undoes a negative 4? I can add 4. Negative 4 plus 4, they cancel out. All right, so I'm just left with an x on this side. 7 and 4 are like terms because neither of them have a variable. So 7 plus 4 is 11. X is 11. Okay. That also means that if I put this half into the calculator, it should equal this half. 11 minus 4 is 7. Yes. Okay. There's nothing different just because we have decimals instead of whole numbers. Okay. You do want to keep the decimals in a straight line if you're going to subtract by hand, right? So y minus 12 equals negative 3.2 minus 6.6. If I wanted to not use my calculator, negative 3.2, negative 6.6. Just make sure to line up the decimals, right? 3 on top of 3 on top of negative 6, 2 on top of 6, decimal point on top of decimal point. Because they're both negative, negative 3.2 and negative 6.6, we add them. 6 plus 2 is 8. Bring down the decimal. 6 plus 3 is 9, and it keeps the sign, right? So negative 9.8. I combined the like terms because there's no x here. Y minus 1.2. Now this looks a little bit like this, where we moved the constant over. We kept the variable on this side. We moved the constant over. Kept the variable x, moved the 4. All right, so now I can do the opposite of minus 1.2. What is the opposite of minus 1.2? I would add 1.2. Anything I do to this side, I have to do to this side. Line it up in case I'm doing it by hand. Now they have different signs, so I'm actually subtracting. 8 minus 2 is 6. 9 minus 1 is 8. Keep the sign of the bigger number because 9 is bigger than 1. So it's negative 8.6. Negative 1.2 plus 1.2 cancels out. So we have y is negative 8.6. I can check this. Negative 8.6 minus 1.2, negative 9.8. Negative 3.2, that, minus 6.6, just like I got here, negative 9.8. So we maintained the equality. This is equal to this when y is this. Okay. Now, remember, I want everything, or I know that everything on the left is equal to everything on the right. Sorry, I stopped numbering them for number 3. I have 6x plus 8 minus 5x equals 8 minus 3. Do you see any like terms? Sorry, the clarity is bothering me. Look at it a little closer. All right. Do you see any like terms? Here, our like terms were negative 3.2 and negative 6.6 because neither of them had y. And then we moved this over because it was actually also a like term. So now, before you move anything, do you see any like terms? We have 8 minus 3 on this side. And on this side, we have 6x minus 5x. Make sure you keep the sign in front of it. 6 minus 5 just becomes x. Bring the 8. 8 minus 3 is 5. So I just changed that from 6x plus 8 minus 5x to x plus 8. 8 minus 3 I changed to 5. Now I need to move the 8 to the right because I want my variables on one side and I want my constants on the other side. Minus 8, minus 8. Now x is negative 3. I should probably check it before I box it. 6 times negative 3. Oops, sorry, you can't even see that. 6 times negative 3 plus 8 minus 5 times negative 3 is a 5. And 8 minus 3 is also a 5. All right. So simplify each side is what I would do first for example 2. Four p minus p, 2 minus 20. 4p minus p becomes 3p. 2 minus 20 becomes negative 18, right? We can keep the 11. We can keep the 2p. So that came straight down. That was the combination of 2 and negative 20. That came straight down. That was the combination of 4 minus 1. Okay. Now it has a variable on the left and the right. We want to move all the variables to the same side or collect them. Okay. It does not matter if you have one on each side. I mean, it never matters. It doesn't matter if you move them this way or that way. Okay. It's up to you. It's light. This light is not good enough today. Okay. So I like to move it this way just because 3p is positive and bigger than 2p. So I know I'll get a positive p if I move it this way. I also just like moving it that way, but it doesn't matter. So if I want to get rid of the positive 2p, I need to subtract 2p. Anything I do to the one side, I do to the other. 3p minus 2p is just p. Minus 11 equals negative 18. Now I need to move that negative 11 over. Now I have p is, because these canceled, p is negative 18 plus 11 is negative 7, right? Yes. So now I've got p is equal to negative 7. We check it. 4 times negative 7 minus 11 minus negative 7, negative 32. 2 plus 2 times negative 7 minus 20, negative 32. So each side is equal. Negative 32 is equal negative 32. All right, this one. Parentheses. I have parentheses. Here we had variables on both sides. Here we have variables on both sides and we have parentheses. But what are these parentheses? These very important parentheses trying to tell me. I cannot combine 3x minus 5. So I can't do it first, right? That's sometimes combine like terms inside the parentheses. That's sometimes what the parentheses are asking. There are no like terms inside the parentheses. There is a 3 outside the parentheses. What could that mean? It could mean distribute what is outside the parentheses through every part of the parentheses. So that is actually what it's saying. 3 times 3x becomes 9x. 3 times negative 5 becomes negative 15. 10x stays the same. Okay? I have a 10 here and a 9 here. So I'm just going to move the 9. Move the 10 if you want. Negative 15 is x, because 10 minus 9 is 1. Check your answer. 3 times 3. I always put my answer in parentheses, just to be safe, right? 3 times 3 times negative 15 minus 5, close the parentheses, negative 150. 10 times negative 15, negative 150. All right. Ooh. 3 times y plus 3 over 5 equals 2y plus 6, okay? We have parentheses. Do what you can to get rid of parentheses, even though there's also a fraction, so we do need to do something with the fraction. But first, get rid of the parentheses, okay? 3y plus 9. 3 times y is 3y. 3 times 3 is 9. So 3y plus 3 becomes 3y plus 9 over 5 is 2y plus 6. Okay? Now, to get rid of fractions, multiply both sides of the equation by a common denominator. Okay? The denominator is the bottom of the fraction. So you have a numerator. Numeration. That's not the word I'm looking for. Numerator. On top, the bottom term is always called the denominator. So our denominator here is 5. Our denominator here is just 1, right? So if you have one denominator, it will be your common denominator because it's common to everything. It's common to 5. 5 is common to 5. If you have more than one, you want to think of what number do all your denominators go into evenly, and then you're going to multiply everything by that number using the distributive property. Okay? So here, our common denominator is 5. So I'm going to say 5. Let's just jump down here. 3y plus 9 over 5 is equal to 2y plus 6. Our common denominator is 5, so I'm going to multiply both sides by 5. Okay? Or it could also be written as 2y plus 6, and I multiply each of those by 5. Okay? So it just depends on how you write it. I'm either going to distribute the 5, or I'm going to write the 5 next to everything. Okay? But here, because both of them are over the 5, I'm not going to write it like this. So 5 times 3y plus 9 over 5 is equal to 5 times 2y plus 5 times 6. Okay? 5 divided by 5 cancels. We are left with 3y plus 9. So by multiplying everything by a common denominator, I got rid of the 5. Over here, 5 times 2y is 10y. 6 times 5 is 30. Or 5 times 2y is 10y, 5 times positive 6 is 30. Okay, now we just solve this the way we were solving them before. Okay, 3y plus 9 equals 10y plus 30. I'm going to move the 9 to this side. Minus 9, minus 9. We got 21. 3y equals 10y plus 21 because it's a positive 21. Different color. Minus 10y minus 10y. Negative 7y equals 21. Divide by negative 7. Divide by negative 7. Negative 7 divided by 7 just leaves us with y. 21 divided by negative 7 is actually a negative 3. Y equals negative 3. Okay, we got rid of the fraction by finding a common denominator. Y is negative 3. Let's check our answer. Start with the parentheses, 3, parentheses, negative 3, plus 3. Close that parentheses, divided by 5. Ooh, I get 0. 2 times negative 3 plus 6. I get 0. All right, it worked. And now let's talk about if I am working on a problem and the variables disappear. Okay, I'm going to give you an example. 5 plus x equals 100 plus x. Okay, I want to move my variables to the left and my constants to the right. So I have a positive x and a positive x. I guess I need to subtract this x to move it, right? Uh-oh. That cancels and that cancels. So now I just have 5 is 100, no x's. This will never be true, right? So we call that no solution. Okay. Alternately, you could say 50 plus 50 plus x equals 100 plus x, right? I want to move my x's over here. So I try to cancel them. Oh no. They're gone again. And now I have 50 plus 50 equals 100. Ooh, but this one is always true, right? So that means there are infinite solutions. They eliminate, but the remaining equation is a true statement. 50 plus 50 will always be 100. So even if I made x equal to 30, then it would be 130 equals 130. So infinite is like infinity, and this is the symbol for infinity. infinite solutions, right? Always true. Let's practice 2 of them. Three x minus 7 equals 3 parentheses x plus 1. First, clear your parentheses. 3 times x, 3 times 1. 3x minus 7 equals 3x plus 3. Okay, let's add 7 to both sides. 3x is 3x plus 10. Yeah, let's move the 3x over. Ten is, oh, there's nothing over here. I have to put a 0. 0 is 10. Is that true? This is never true. So we say no solution, and we put a line through the equal sign. 0 is not equal to 10. Okay? Alternately, 5x minus 5 equals 2x plus 1 plus 3x minus 7. 5x minus 5 equals, I'm going to distribute the 2x. 2x plus 2 plus 3x minus 7. Now I'm going to combine like terms. 2 plus 3x, 2 minus 7. 5x minus 5 equals 2x plus 3x is 5x. 2 minus 7 is negative 5. Ooh, look at that. The left side is exactly the same value as the right. Right? They are the same. Okay? So I could keep going, or I could just say, it looks like it will always be true, right? Whatever number I put here, the equation will stay true, right? 5 times 10 minus 5 is still equal 5 times 10 minus 5, no matter what number I choose. Or I could keep going. I could add 5 to both sides. And I would just have 5x equals 5x. I could divide both sides by 5. Right? X will always equal x. Okay? It will always be true. Oops, sorry. So that one is always true. Infinite solutions. X can be any number. Always true, infinite solutions. X can be any number and it will always be a true statement. So today was about solving equations. Here are the important points. Anything you do to one side, you have to do to the other. Rules don't change with decimals. Collect like terms first. Move variables to one side, constants to the other side. Work with parentheses first, either by combining like terms inside the parentheses or distributing something that is outside the parentheses. Clear fractions by finding a common denominator and multiply everything by that common denominator. All right. Thank you guys so much. See you next time.